Okay. Aren't you doing a lot of this in physics right now? Okay, and then what about acceleration? I've got a velocity graph. How am I supposed to get acceleration out of it? We've talked about how you could take the derivative of velocity to get acceleration, but I don't know, I don't have a function.
Rise over run.
Okay, what does rise over run give us? And what is the calculus word for slope? Okay, so the derivative of v is how we figure out about a, and the way you figure out the derivative of v, the slope of this, I'm sorry, the derivative means slope, so we're really just looking at the slope of each of these. During this time, what's the acceleration? 0, and let's put some units here. Let's say velocity is like meters per second, so acceleration would be meters per second squared. How can I compute this acceleration?
6.
Okay, and how'd you do that?
60 over 10.
All right, rise over run is slope. Slope means derivative. Derivative of velocity gives you acceleration. So 6 meters per second squared. Let's do this other one down here. If we did rise over run, looks like it's going up 40, right 15. Could divide both by 5, so like 8/3 meters per second squared. Is that right? You guys okay with where I'm getting those numbers? Okay, and then let's say I did this one and I did rise over run. It looks like it is changing 100 over 5, 10, 15, 20, 25. So that would be 4 meters per second squared. It has to be negative, because it's negative slope, so it should be negative derivative. So, especially if you compare this to like using the product rule and quotient rule, which we need to be able to do as well, these questions are kind of nice because they don't take a lot of steps. But you have to know to go to the right, velocity has to be positive. It only goes to the left when velocity is negative. So that we were looking at certain parts of our graph. Positive is above the x-axis, negative is below the x-axis. When velocity is 0, it's not moving, so that would be when it's on the x-axis, y is 0. And then to find acceleration, you have to understand that acceleration is the same as the derivative of velocity, and the way you're supposed to know the derivative of velocity without the function and taking the derivative is that derivative means slope. So kind of rise over run, 1, 2, 3, 4 segments can get you the acceleration at any given time. Okay, that's all of that we're looking at today. So if y'all want to ask anything to clarify there, now would be the time. No? Okay. So please find your bookwork from the other day, number 22. I think I'd asked you to get through number 65? 35. Are you sure it's 35?
Yeah.
Okay. Wherever you're at the end of the day, you need to get all the practice in anyway. So go ahead and start on the question that you were left off on. I don't think any of those notes we just talked about comes up in the bookwork. Should just be practicing product rule and quotient rule and maybe your calculator a little bit. But those type of questions take a lot more practice. So that's why we're giving you a bigger assignment, but also more class time to digest that information. So I will give you a few moments here to try to get a few more questions under your belt, and then I'll come around and help the rest of the time. Oh, I'm sorry. Before y'all get going on that, I do need you to turn in the assignment in the Google Classroom. I think I have it due by the end of the class. That's not this book assignment, it's the one before. So it was 2 classes ago. That would be number 20. Check to see if you turn that in before you keep going. I want to give you some points for that. And it was supposed to be done before you came to class last time, so it should certainly be done by now. If I don't have that in the classroom by the end of class, then it will be late credit. So do that now so you don't forget.
I think I left that sheet with my folder at home from like last week, like for her first one we did.
Well, you'll still turn it in the Google Classroom, but do you have your binder for this class?
Not with me. I only brought the textbook.
Okay, you need to bring your binder with you on paydays.
Yeah, is it fine if will I still get points if I submit it when I get back home?
Yes.
Okay, thank you. I was absent on Friday.
Okay, it's been a week, so you should be caught up by now.
Okay.
Do you know where to find the class videos so that you know what you're missing?
I was trying yesterday on my YouTube was bad on my Chromebook.
Yeah, I don't know about that. If it's your Chromebook, you need to go to the tech center or something, but you've had time to get it caught up.
Like on 27, would you factor and cancel first? Make it easier. I tried that and then I got
If it factors.
yeah. I did that and then I got 1, but it's not what they got in my book.
See, look, when you change this to this,
Yeah.
all the signs changed. So you factored out a negative, but you didn't write the negative there.
On the bottom too?
Did you switch the signs?
Yes. On the top I did. I didn't do it on the bottom.
If you only did it on top, then you created a negative on top.
Okay.
So what was your answer and what was theirs?
Like this canceled out.
Okay.
And I got 1 because taking the derivative of these, cancel this out and do 1 over 1.
Okay, wait. Now, if we're talking about derivatives, you don't get to just take the derivative of this, and then take the derivative of this, and then slap a divide sign in between. That's why we have the quotient rule, because it doesn't work like that. You still have to do the quotient rule on that. Before you get going on here, you need to turn in the book assignment from 2 classes ago.
21 or 20?
20.
Okay.
It's doing Google Classroom by the end of class, so.
Can I just give it to you? Or would you prefer I turn it in by?
Yes, you can. but I need to make it in gradebook so I can put it in.
Do we have a 21?
21 was the notes over product rule, quotient rule, and trig identities.
Okay.
No, I just was trying to see what I was doing wrong here, but I figured it out.
Okay. Okay. Okay, so to write the equation of the tangent line, that's where we're gonna make a point slope. So, like that, okay, you've already started that. So the point, they're given to you, so they'll give you like -5 then for x, 5 for y1, that looks good. And then to find the slope is gonna come from the derivative at x equals -5. So you've gotta take this derivative, plug in -5 to it, and then you know the slope of that instant. Help good? Well, this is what you're supposed to practice.
Yeah, we're going over this part of it. But I didn't know the
No,
C
you're
thing.
supposed to practice more of the questions that you have.
Yeah,
That you
yeah.
try it. What are your questions?
Yeah.
I can't show you how to do
What
the
is
whole
the
thing.
C?
They want you to find the derivative, the product rule of quotient,
Okay, yeah.
and then second answer, plug that number into the derivative and get another answer.
Oh, okay.
I think book's gonna have two answers, one's the derivative and one's the derivative at that value. Any giving you issues yet?
What?
Any of them giving you problems yet?
This was, I did that, I was getting in trouble when I was doing it for,
Okay. What is it? One. What's the question like?
it said find the derivative of the algebraic function.
Okay, so how would you take the derivative of that?
Well, so, what I was trying to figure out, would I just distribute x into it?
I would.
Okay, yeah, if that's what it is, then I'm taking there.
Distribute and then derivative of each part. The first term is gonna be easy, I think, because this is gonna be x.
Yeah,
But this, you're gonna have to use quotient rule on.
yeah, and I'll have to do that either way,
That's true.
so I might as well just distribute x.
Okay. Let me see the original question again. Here's where you got a mistake going on. When you took the derivative of the numerator, I've got -2x minus 3, like you did. And then that's times the denominator left alone, right? So it's all of this times all of this. But then in the next step, you only get this times the second term, not times the first term. Oh, actually, never mind. You did distribute. You did distribute that, so let's see that. Okay, that part is fine. Minus. Okay, that set it correctly. Distributed. Why is, how do you, so like, I know you can factor out the 3 out of this.
Yeah.
So maybe that's where the 3's coming from. I don't know. Put a star, yeah, try and finish it, but put a star by it. I'm gonna work it separately, because I don't really see what's wrong with yours, so I might be lost and we're the same thing, so. Let me try it from scratch now.
Which one is it?
Are you done already?
I'm trying to see if I got that one. Yeah, I just.
How you doing?
Here's my work. But I think that's like a link. Is it different than yours?
Oh, yeah. You just, yeah. I need a pack that. And then pack with text where you cancel out.
Yeah.
Thank you. I agree.
All of your stuff is right there.
Yeah.
I just have to keep going. If you factor out that 3 and then you use the denominators that times itself and factor and then cancel stuff out.
I have a question. So I'm not really sure how to go about 63
Okay.
because, well, I didn't do that at first, so I graphed it, and the graph doesn't even go down to -3. And also, for this one, it's like division, so I can use the quotient rule.
So that, I want you to use the quotient rule first.
But it's plus, it's not like multiplying. So I would not like to do that.
That doesn't have anything to do with it. If it's something divided by something, you can do the quotient rule.
But doesn't it have to be something times something?
The product rule, not quotient rule.
Right?
Product means multiply. That's where you need something multiplied.
But I thought that.
Okay, so the pattern, sure. So what is the derivative of the numerator?
It's just negative.
Okay, so you gotta write that down. Okay, times the denominator left alone.
Oh, yeah, you're right, I got it now. And then when it comes to substituting, or this point, do I just substitute it as x? Cause, and then make it equal to -3?
You don't need the negative root at all. The derivative is like a formula that tells you the slope for any x value. So if you wanna know the slope at the derivative of pi over 3, you just plug it in pi over 3, or pi over 3.
Okay, and so how do I check it with the graph if the graph doesn't go to? Let me check it out.
well, you're typing in inverse. Inverse and reciprocal are two different things. So this is inverse cosine. What you meant was reciprocal cosine, which is 1 over cosine. Like that. Same thing. Cosecant is the same as 1 over cosine. And so, let me know the box. Oh, good. We gotta put a letter here. So X is our variable. And you wanna know at 5 or 6. It's in ready mode, so it looks like it should come out to be 0. So after you do the derivative by hand, plug in 5 or 6, and then if it all turns out to be 0, then it's fine.
Oh. Just one over some.
Just the right graph of a differentiable function such that f is greater than 0. What does that mean? So it's always above the,
Always above the X.
okay. So it's always above the x-axis. And what else? do we need? And the derivative needs to be negative. And derivative is like slope. So you need to graph a line that has a negative slope. This would eventually give you a y value that's negative. Like that. Always positive. And the slope's always, it's close to 0, but as long as it keeps going down slowly. So, that's one possible answer. You just need to say something about, this means the graph needs to be above the x-axis the whole time, this means that the slope has to be negative. So as long as your picture matches those two things, then that it can look good. Where's your original? The first times the second less one. Okay, the problem is here when you're doing it this way. You're taking the derivative of. Yeah, and so that's just gonna get real messy. So. I don't see your mistake immediately, but what's gonna make that question a whole lot easier if you just distribute that x at the beginning. Is that right? If you just distribute it. This derivative is 1, that's quick. And then this derivative is a much easier quotient flow. And then you're not trying to do product and quotient together.
So,
Probably, no. I didn't see it off the top of my head, so.
slow for another class and finish this up.
Working on. What you working on? Trying to check it. Calculator?
Yeah. It says for the second part, the use your graphic calculator to check it.
Okay.
What is a transcendental?
Transcendental just means like it has something like e to the x or a
Okay.
logarithm or something in there.
Okay, cool.
Some calculus textbooks don't show those until later in the year, and
Mhm.
some show them early in the year.
Mhm.
See right here. Ours is early,
Okay.
so you see it earlier in the year.
Okay.
You get more time to practice it.
That's nice.
Well, the flip is you have more thrown at you at the beginning of the year too.
Yeah.
So. Okay, I know I really emphasized this last class, but as you guys are going through this book assignment, again, every few questions you need to feel like you're getting a little bit better at what you're doing. Looking at the product rule, quotient rule, patterns less power rule mistakes, less looking up the memorized ones, the memorized derivatives.
I just distributed it to the top, so it's 4x.
Okay, I'm gonna put a couple of these homework papers in grade book, and then I'll come back around. Y'all don't seem like you have questions ready yet, anyway.
Thousand. This is what we're turning in. Just turn it in.
Here, wait, I just put it in, so you don't have to scan it.
Okay.
Wait, don't run up. You need it back. I thought this is what you had at home.
Oh yeah, but I found it just stashed in my folder because.
Sorry, really quick.
No, you're not.
For this, would I use the product rule 2 times?
Yeah, you're gonna have to. Product rule for this side and then product rule for that side.
Okay.
It's so much work.
It is. derivative manually.
I was wondering if you'd be able to send me that.
Can you come back later?
Yes, and should I come back later for my assignment?
You can grab those if you know where they're at. If you need my help, then you'll have to wait. But-
Okay.
Okay, so you did this. You already did the manual one. Okay. So it wants to know the derivative at that point. So now if you plug in pi over 6 into what you have left over, you should come up with a numeric answer, a number answer. And then they want you to just take the derivative of this in your calculator at that point to see that it's the same number. That way you get a little bit of
Do you remember that first problem, that 0 when you put it in the calculator?
no.
Well, we did, and, for this one, I got negative 167, or 4 divided by 0 point something, or 0.63. And the answer for that, it said on the back, was 4 times the square root of.
Okay, maybe the rest wasn't typed in correctly, let's see. Guessing that it wasn't typed in correctly. So, what was the original? 1 plus cosecant. That might have been the problem. Reciprocal of cosecant is something, I feel like I might have had cosecant.
Oh, yeah.
And then it said the answer was what? Negative 4 square root of 3 or something? Put a piece of paper or something back there so you don't have to find it as much. Negative 4 square root of 3. Okay, so negative 4. Okay, so that's still. It's something about how I'm typing it in, but let me give one other tip here. Do you know how to do fractions other than just parentheses in your calculator? Because that's making it hard for me to read.
Isn't it like math fraction?
Yeah. Well, that changes something to a fraction. But if you do alpha y equals, this first one says like do numerator over denominator. And then it's a little bit easier to make it look like it's supposed to be. See how it looks more similar to the question now. Okay, what's the bottom? Is it 1 minus?
Yeah.
Negative 4 square root of 3. Oh, I'm doing pi over 4, it's supposed to be pi over 6. Okay, now,
Thank you.
yeah, so I usually do fractions, I think the same way you were with a bunch of parentheses. The problem is when you've got fractions within fractions, if you don't get those parentheses just perfect, it's kind of hard. So if you do alpha y equals, you do your fraction like this instead, it's a little bit easier to keep up that it like looks right, so.
Okay.
Something like that.
double prime on the same coordinate axis, identify which is which. Okay, let's say, okay, so 17. So to me, it looks like this one might be cubic, the way it's turning like this. This one's probably a parabola, and this one's probably linear. So, if the function was something cubic, it's not the same function, but if it was that, what would the derivative be? Okay. And what would the second derivative be? So, notice as you take the derivative, the power goes down, which means you have less curvature in your graph. So, that one, probably like, the first one, the function graph, I think is some sort of quadratic. The first derivative is some sort of linear function. Oh, no, so which one of these has the least curvature? This got to be the second. And then the one with only one turning point, its degree would be one higher, so that would be the parabola, and then this would have to be the function. So, and then what about over here? No, just which one would be the function, which would be the first derivative, and what would be the second derivative, not what the function is. No. So in 18, which one of those would probably be the function? Because then the derivative would be linear, and his slope, his derivative would be 0. Right? The only way to do cosecant here, and with this big fraction, you might want to do alpha y equals option 1, and then you can type it in like this. But the only way to type in cosecant is to do 1 over sine, like that. Cosecant's 1 over sine. Anything specific on the back? Now let me work it up here for a second. I can't tell.
So it looks like the only thing, I don't know that you carried your 1 down. I know you had it at one point, but if you carry it down and then you're comparing this to what they had, I thought about changing this 1 with the common denominator.
Okay.
You see how I rewrote 1 like this?
Yeah.
Then they had a common denominator, and I FOILed this out and combined his +9 with his -12. So, again, pretty unusual. You don't normally need to simplify that much for a question, but
Okay, so what it looks like you're typing in your answer, what you got for the derivative. So you're asking your calculator, what's the derivative of the derivative at pi over 6? You need to just type in the original function at pi over 6, and then it should be the same as your answer at pi over 6. That should be the same.
I end up getting y equals 2x minus y equals 1.
Okay.
But the answer is basically just that multiplied by 2.
Okay. They chose not to have this fraction, would be my guess.
I mean,
that's not, so it's not the end of the world. Like, who would have thought to have done that? But, like, again, when you do this on a test, and you're confident in this, and one of the choices where they just multiplied everything by 2, you can at least figure out which one you need to pick. Okay. That's all that matters. I'm doing a good job of asking questions, but please keep them coming. Only so much I can help outside of class.
I understand that you're supposed to find the line and make the graph.
Okay.
I took the derivative of this
Okay.
and I got this, which is
Alright, well wait, first of all, how do you write the equation of the tangent line?
well, I thought you need to have like something with an equation something.
Okay, equality. To write an equation, any equation of a line, as long as it's linear, we do point slope. Y minus y1 equals 10, parentheses x minus x1. So that's not sense. Okay, so write that out. Now let's slope formula. I'm talking about point slope. Y minus y1. No, y, equals slope, parentheses, basically multiply this over, multiply that over, and that's. That's the easiest way to make the equation of the tangent line. Because what you need is a point, and then they give you a point. -5, 5. So in place of x1, you put -5.
Place the y1 equals 5. Okay, so that's just waiting on x. But the slope has to come from the derivative at that x value. So now we'll worry about the calculation. So what was the function, what was the derivative? Okay, so at -5, so plug in -5 in for x there and see what it comes out to be. Okay, so therefore the slope when x is -5 must be 4. So plug in a 4 there, and then that should be close to what they have, not exactly the same. They might have added that -5 over.
The derivative is y. Oh, it's y.
I wouldn't even do that unless you saw what you needed to. Just leave it in point slope, 'cause it's less work.
And then do I just graph? Because I have to draw a graph.
Yeah, you just throw it in the calculator, it's fine. So they probably want you to graph the original problem and graph this at the same time. And then if this is really a tangent line, it should be touching it one time only, and it should be exactly when x is -5. It should just graze past it most. You finish that one?
Which one?
I
Oh,
don't know,
this
the
one?
one you were.
Oh, this one. That one actually didn't end up taking that long. This one did though. The one where I had to do, that one took forever, but that's okay. At least
But it worked out, okay.
yeah, at least I'm figuring it out. How did you like memorize the, do you have like a way that you memorize the derivative and trig functions?
Well,
Or did
the
you just,
derivative
like-
of sine and cosine, we use so
Yeah.
much that I know those.
Yeah, and then tangent.
Tangent is secant squared. That one gets used quite a bit too. I know that if you take the derivative of a trig function that doesn't start with the letter C, it's positive.
And then like, okay. and
Like
then
the
C
derivative of
is negative.
sine, it's positive something. Tangent is something positive something.
And then,
And secant is positive something. But the derivative of everything that starts with C is negative.
mhm.
I know tangent is secant squared, and then kind of the same pattern, the derivative of cotangent is cosecant squared.
Okay,
To me, those
okay, that makes sense.
kind of are similar format, type. And then the other two,
Don't they both have tangent?
yeah, and themselves. So cosecant is negative cosecant cotangent, I think.
Mhm.
And secant is a positive secant tangent.
Yeah.
So,
Just have
I
to
don't know.
memorize it. There's not really a trick.
I mean, there's a few patterns in there, but yeah, not enough to. I mean, you can also, like, again, this is a lot, and you don't want to rely on this long term, but like, if you just were desperate to know the derivative of secant and you just couldn't remember,
Yeah.
you could rewrite it with trig identities, like
Yeah.
call it this, And then if you could do the quotient rule, derivative of the top with the bottom left alone minus the derivative of the bottom with the top left alone all over the denominator squared, you end up with sine over cosine squared, which is like sine over cosine times cosine, which is like this is secant and that is tangent. So it's possible to derive it in the moment, but
Okay.
that's kind of time consuming too.
Yeah.
So. Derivative of this would be a square root of t down there.
Oh,
Because when you lower the power by 1, and bring the power down, you have to lower the power by 1. Yeah, because it's negative, you move it to the denominator, but it's still going to be to the 1/2.
okay.
So he's got to be the square root. Derivative of that, is that left alone? Okay, so technically this is the derivative, which
And then
is
we need to simplify a little bit.
sometimes, yeah, it just depends on the question. This one, I think they looked at this as a big fraction because it has a denominator, and I think they get this one to have the same denominator so that they can push those together.
Okay.
Pretty sure we did that one together, so that one should be on the class recording, I think, but sometimes the simplifying's nothing and sometimes it's a real pain. You need to practice until you get it to match up the back of the book. I don't know, I can't do that fast. X minus X plus 4. Yeah, that looks good. Well, this is the derivative. What did they want for question 69? You probably needed the derivative, but it may not be asked for that. Yeah, it wants the equation of the tangent line. Point slope. For all tangent lines. What point do you want it to go through? -5. What? 5. Okay, so they're giving you x1, y1, a point. The slope is going to come from the derivative. So what is the derivative at x equals -5? You need to plug in -5 into your derivative here. What do you get? 4. Okay. And then I think they just solved this with y equals maybe 4x. This would be 20. Add the 5 over. Is that what they have in the back? Because it's two different things. The derivative helps you understand slope, but they're asking for the tangent line. So your function might have looked like this, and they're wanting to know what's the line that does that at x equals -5. We did, there's one like that on your notes, if you go back a few class periods.
Question, I don't fully know what's asking. Is this talking about time and the
Rate of change of area. Well, what's another word for rate of change? Starts with an S. Well, kind of, yeah, but slope, and then what's another word for slope?
derivative.
Okay, so if they want area, so length times width,
Yeah.
so multiply those two together is your area.
Okay, and then you
And then if you want to know the rate, instantaneous rate of change of area, that's the same as derivative.
Okay.
They're asking you to do length times width and do derivative.
Okay, yeah.
Did you ever get that?
Yes.
Well, areas, kind of width. Rate of change in the slope, which is derivative. So you do the derivative using product rule. Okay. I don't know what the problem is, so. Like, what step do you think might be wrong? Like, I don't know what the original function is to know. What is this guy's denominator? This guy's. Okay. I think they're saying get a common denominator and add those together. So multiply the top and bottom of that by 2/3 and then run it as a funny fraction. I think that's what we're doing.
So, right here, assuming
Okay. So 113, you need to worry about the derivative first. So it's going to be not that. You can't just take the derivative of the numerator and then take the derivative of the denominator. You'll have to divide by it. You have to use the whole quotient rule. Anytime you want the derivative of something divided by something, you have to go to the whole quotient rule. So write out derivative of g times h minus derivative of h times g all over h squared, and then plug in the pieces from those directions.
Can I put this in the calculator?
Well, secant is 1 over what? It has to be 1 over cosine. And you're going to say that's equivalent to and square that. I don't like that box you have out there. Here, do it again, but you don't have the clock's not the way. Alright, so now if you also grab this, if this is right, it should be the line that touches at that same point, and it should just raise your equation where it always touches at that line. That's what it means to
Alright guys, I'm sorry I didn't give you much warning there, but we've only got about a couple minutes here. So for homework, please try the rest of these questions. All of these are worked out as separate individual videos on the website so that you can get exactly what you need. Please use those to help you get caught up to everybody else. It's fine if you're struggling, but you got to start moving in the right direction so that you're not falling behind others.